Welcome back.
Hi everybody, welcome back.
P6.
All right, lesson P6 is still solving, but this time we are solving inequalities instead of equations.
So they're not equal.
They're not equal.
Sometimes they are.
Sometimes, or equal too. All right, so Mr. Leckie's got some rules for us.
All right, rules. We have the algebraic rule that you can memorize and just apply it every time, okay? Here's what we're going to do. We're talking about absolute values and whether or not they're greater than or less than a certain number, okay? So if the absolute value of u, or anything that's inside of there, is less than a, then what we know is that u is between positive a and negative a. That's the rule. If you want to memorize it and use it, great. I'm going to try to show you a way to remember it. That is a little weird and corny.
Well,
but,
it'll just make more sense.
It'll make more sense,
remember.
okay? Or we have the second rule that says if the absolute value of u is greater than a, then u is less than negative a, or u is greater than a, and you're going to have to do both sides and solve both inequalities.
So let's show them why this happens.
All right, so let's pretend that you are represented, or the you in here is represented by a person, okay?
You.
You, that's you. All right. And the absolute value of u then represents your distance from 0.
Yes, we talked about that last class.
Absolute value is a distance. Okay, so absolute value of u is greater than 5, which means your distance away from 0 is bigger than 5. So let's pretend you live on a number line and your life is very boring. You have to be more than 5 spaces from 0.
Okay.
So where are you allowed to live?
You could be at 5.
You could be at 5, but then you have to be more than 5 spaces from 0. So you're allowed to live anywhere
To
out
the right
here
of 5.
over on this
Nice.
side. Yes?
Over there.
Okay, or you could live to the left of 0, and you would have to live over here.
Okay.
Yes?
Yes.
So your living space is going to be this direction or that direction only.
And this is how I remember that. If you think of the 0 being right here, okay, and the
She's a
distance
0.
5,
Go ahead.
I am centered. and the distance of 5 units, you can live out there. Further.
I almost got hit. Okay.
You deserved it.
So what you have then is you have two inequalities. You have the one that's over here, which is literally u. I can't draw a stick figure.
I see that.
Is less than negative 5. Or you could be way over here and be greater than positive 5. And this says the same thing as rule number 2.
Okay?
All right, what if u now is less than 5?
All right?
So where are you allowed to live?
Well, you are allowed to live anything that's not 5 units, less than 5 units. So you could live between negative 5 and positive 5. Again.
You can't go further away than 5 spaces.
No,
you
you
have to be less than 5 spaces from 0.
Short
It's like you're on a
legs.
leash. You're on a leash, and this one up here is like they have a restraining order against you. If you come within
Keep a
that,
bubble. Stay out of my bubble.
you're not allowed. You're dead.
Well, what I was going to say is if the distance is greater than, watch out, you're going to get hit.
I'm
And
having-
you're out there. Or if the distance is less than, then you're in there. Out
In
there,
here.
in there.
Which means that you are stuck
Between.
or tethered to your leash
Yes.
between negative 5 and 5.
Now, Mr. Lucky, you're writing inequalities here, but our answers are going to be written.
As intervals
Intervals.
when we're done.
Okay, let's
Or
do
we're
some
gonna
examples.
write the inequalities so we can solve them.
Yeah, we've sufficiently confused them, so let's
I
give
hope
some
not.
specific examples.
We got the swimming thing going on.
It's not swimming, it's in there and out there.
All right,
Makes
you want to do
perfect
the problem?
sense. Sure.
Can
Let
I
me see
do
if we
this?
got it. Sure. Just don't hit me in the head. All right.
Remember, she's the 0.
Just
and you're
like
going-
I'm centered. No, just like last class, we want to make sure that our absolute value is isolated first. And so this first problem, letter A, already has the absolute value isolated. Okay.
Big
so
words.
all we need to do now is apply the definition of absolute value, which says that our distance from 0. Okay. So our distance, in this case, has to be more. That's what greater than means. Than 35. Okay. Our math teacher.
Distant more 35.
Okay.
Got it.
So what does that mean? Well, again, you could draw a picture, okay, and that means your distance has to be more than 35, so you could be over there. So we're going to write an inequality equation, or an inequality to solve for that. So either 2x
notice
minus 1.
she's not changing the inside of the absolute value at all.
Never, ever, ever,
We're
ever.
not going to.
Okay.
Plain and simple.
So this arrow right here is represented by this inequality that we can now solve, okay? But not only could we be more than the positive 35,
We could be smaller than negative 35.
we could be smaller than negative 35.
the left flap.
Okay, so 2x minus 1 could be less than a negative 35. Again, we're never making this inside the inequality negative. We're saying that our value can be less than the negative.
All right, once you break this up into two spots, it's very simple to solve. You do
Easy
your
peasy.
Algebra 1 skills. Failure to break this up into two pieces means you don't really get it.
And breaking them up incorrectly
Yeah.
is a problem as well, which
So-
we see a lot. So we're trying to help prevent you from making that same mistake.
And remember, these are going to go in two separate directions, so our intervals for our final answer should also be in two separate directions.
Okay, and the intervals are pretty easy to do. Again, if you've gone back up to this picture, this was negative infinity, and this was infinity. So we're saying from negative infinity up to 35, but we cannot include it because of this symbol. Okay? Or I'm sorry, it's not 35 anymore, it's 17 because I solved, but you get the idea.
So we are less than negative 17,
Okay.
and then we are bigger than 18. And for those of you that are really catching on to this, guess how far apart 18 and negative 17 are?
35 units.
Wow. Crazy.
Okay? So there's your restraining order. It's you have to be further away than 35 units. Go away. No, I'm kidding.
Go away.
All right, what if we try the second one? Well, the only difference between letter B and letter A is there's more stuff around our absolute value, and we have an or equal to. Okay? So let's go ahead and give it a try. What should we do first?
We get rid of the 13 by subtracting it from both sides.
Okay.
And 9 minus 13 is negative 4. Then we divide by negative 4, but what happens when we divide an inequality by a negative number on both sides?
Oh, it changes or reverses the
notice
inequality.
that? Weird.
Multiplication or division.
By
Okay,
a
so be
negative.
careful.
All right, now we have an absolute value of 3 minus 4x is less than or equal to 1, which means we are stuck between 1 and negative 1. We're on a leash, or whatever she was just doing with her arms.
We can go 1 unit that way.
And because
one
we're
unit that
stuck
way.
between two numbers, we can do this as one inequality with 3 pieces to it, really. So we have negative 1 less than or equal to 3 minus 4x is less than or equal to positive 1.
Okay, we solved this the other day.
Subtract 3 from all 3 parts. We get negative 4 less than or equal to negative 4x less than or equal to negative 2. And then we divide by negative 4 again, which
Again.
when you divide by negative 4 in an inequality switches all the inequality signs. And this time there are 2 of them, so they both turn around. By the way, you'll never write things as a string with inequalities going 2 separate directions.
Never. If you start with a less than, the next one's a less than. If you start with a greater than, the next one's a greater than.
Now, how do we write this in interval notation? Because we're not going to write 1 comma 1/2 because 1 is bigger than a half.
Okay, we might want to think of a picture first. What are we saying? We're saying all values between 1/2, right,
And
1. Now that picture is much easier to write our inequality, our interval rather.
And please, if you are having trouble writing your brackets or your intervals, then go ahead and draw a number line if you need to help yourself out. But make sure you got brackets around the 1/2 of the 1, and that'll do it for inequality
Now,
or interval.
one thing that's interesting, when you go to check these problems, the easiest way to check them is to actually pick a value that makes this true. So pick like something 3/4 and then plug it into your original x, and that'll make
See if it works.
an answer that works. Otherwise, if you pick the 1/2 or the 1, you're actually going to get something equal to 9, and that might mess you up on
Because
this
you don't know
kind
if
of
it's going
question.
left or right of those numbers at that
Right.
point.
Right, and on this question, then you'll say 35 equals 35, and you'll panic and think you did it wrong, and you didn't. Okay?
All right, now how else are we going to do this?
Well, of course, graphically always helps things, okay? So instead of just drawing on a number line, we can go back to the same 2 original questions, and we can graph with this being our y1. And
So we're going
this
to take out our
being
graphing
y2.
calculator and just graph both sides?
Yep, and we did that last class.
Okay.
But this inequality is kind of interesting. Mr. Lucky, what does that mean?
That means greater than. Or
Okay.
in this case, we want y1 to be greater than y2. I'm not sure why there's 2 y2s, but we want y1 to be greater than y2. And on a graph, the y values go up and down. So really what this means is we want y1, or the absolute value graph, the V-shaped graph, to be higher or above or more than or bigger than the horizontal line y equals 35.
Okay, so if we look on this graph, and I get my highlighter, do I have to, I gotta do that.
Where's our V shape above our line?
Well, we're talking about over here and over here, so we're probably gonna need, like we did last class, to find the intersections.
So we go second, calc, 5,
Right,
first curve, second curve, guess?
right. And we should already know what those were from the last question.
Okay.
They
They
were
were negative 17 and 18.
negative 17 and 18. So we know that this is at negative 17, I forgot already, and this is 18.
And those
Okay.
are the x values.
Those are the x
those
values.
points hit each other.
But again, since it's a greater than, we're talking about the distance being out there, okay? So if we look at the x-axis, we need these values and these values to the right over here.
Yep. So how do we describe those in an interval?
Again, here's negative infinity, here was our negative 17, here was 18, and here's our infinity. So we're going to say from negative infinity to negative 17. Never, never include negative infinity. We don't include the negative 17 because this is more than, not, or equal to. Okay? And then union with our 18
to infinity.
Okay? So you might want to hit pause, try letter B, make sure you can get it all typed into the calculator correctly, and then come on back to make sure you got it right.
So this time we want y1 to be bigger than or equal to y2. Again, that means we want the absolute value curve or the V-shaped graph to be above the line or more than, okay? But in this case, that is going to be that little V-shaped hump that is above the line. Right there. So we find the intersection point, so we have some reference points to deal with.
So those were at 1/2.
And 1.
And 1.
That's not 1, but okay.
Yeah. You're so high maintenance.
I'm high maintenance. We don't want to label the x-intercept. We want to label where the intersect.
Thank you. You're right. Common mistake. Thank
All right.
you.
So there's a 1. And this time, though, where's our answers? It's between them, because between 1/2 and 1, the V is above the line.
Correct.
So our answers at the interval between 1/2 and 1, and we look at our original problem to determine whether we include the endpoints. Because it says greater than or equal to, we can be equal to or including the intersection points.
So we use the bracket. Okay?
Easy enough.
And again, the answer should match if it's the same question. All right, so what if we're doing inequalities that are not on absolute value? Well, we're going to primarily focus on this graphically. Later on, we will do them algebraically, okay, just as a heads up. But for right now, we're going to focus on them graphically, and you probably do this again in Algebra 2. So again, if we want to graphically solve when x cubed plus x squared plus 6x is less than 0, what are we saying? Well, if we let this be our y1 and type it in, we want to know when is our y1. Now, since this is a 0, instead of comparing a curve and a line or something like that, you want to think of this as being less than 0 or negative. Where is the y value? Where are the y values? Negative. In other words, below the x-axis.
Now you could draw y2 as 0 and draw, but it's just going to draw a line down the x-axis. That's all.
And then
it's
you
gonna
won't
do.
see it, and you'll think you did something wrong.
Exactly. So, but we're looking for where the y values are below 0 or where the y values are negative. So we're below the x-axis, and Mrs. Schofield has highlighted those sections. All we have to do is describe those intervals.
Which means we need to use our calculator to find those actual zeros. Okay.
Lucky for you, we did it for you. But
Yep.
again, if you can calculate those zeros, they are -3, 0, and 2.
Those are awfully nice numbers. I wonder if that means this was factorable.
Always. We'll get to that later, but
Okay.
for now, and some of the ones on our worksheets in class will not be pretty, but it doesn't change the fact that
Right.
we do this the same way.
If it's a decimal, round to 3 places.
Absolutely.
Okay, so this first chunk over here
Would be
we-
less than -3.
Yeah, we need to be to the left of -3, so that's from negative infinity to -3. Can we include our negative infinity?
Since we did not have a equal
Can
to
we
sign.
include our
Oh
negative
no,
infinity?
never including negative infinity.
Can we include our -3?
First step, listen to the question before you answer whatever you feel like.
I tricked him. We cannot include the -3 is what he was starting to say, Mr. Lecky, because this is less than.
That's what I
or
was
equal
gonna say.
to. Okay, we've got another chunk, though, where we're below, and that would be from there to there.
From 0 to 2,
So
and
we're
again,
gonna include-
we're not including those because
Thank
we
you.
did not have an equal to sign on our inequality.
Very nice.
All right, that'll do it for example 6.
Okay, so we've covered some quadratics here. We've covered absolute value. One more kind of problem.
All right.
You want to write yet?
Oh, sure, why not? I've been sitting on my butt the
Yeah,
whole time.
get up already.
All right.
Now give me the answers.
Okay. The height h in feet of a projectile at t seconds after it has been launched vertically from an initial height of h naught feet above the ground, blah, 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 blah. What do you need out of this? This thing right here is going to model something that you launch into the air. The v naught is your initial velocity,
Sometimes that's called v sub 0.
v sub 0, so it's how fast you launch the thing into the air. And h naught, or h sub 0, is your initial, that little sub 0 thing, is your initial height.
Yeah, or height at time 0. That's
So
how I used to
what
refer
it really means is when you graph this, you're going to have time versus height. And wherever you are initially, that would be your height. You're launching it into the air. It's a parabola that opens down. And so you're going to basically get an upside down parabola with time versus height.
Okay, so there's a
Okay.
whole bunch of variables here, but we're not going to end up using all of them as variables. We need some numbers.
We're going to
so
plug everything in. So if an object is launched with an initial velocity of 256, so our v naught is 256 feet per second.
6.
That
See,
would be
you
a
do it
6
too.
and not an F.
Your brain skips.
Uh-huh. And by the way, this equation works in feet per second, or feet for height and seconds for time. If we were in meters, it would actually be negative 4.9 t squared plus v naught t plus h naught.
Right.
Okay, for those of you who happen to be in a physics class right now, I wonder why
Probably
it's
do a
different.
lot with meters, yeah.
H naught, and this is the one where I like this example because this is the one that if we tell you the initial height was 12 feet off the ground, people get it right.
Right.
But when we tell you it was launched from the ground, people are confused.
Hey, Mr. Leckie, what's the height when you're on the ground?
0.
0.
So the initial height is 0. So how are we going to write this equation? We're going to write h of t is going to be negative 16
So
t
the negative
squared.
16 is always there?
Always there.
Okay.
It's actually half the pull of gravity
Nice.
in feet per second
Plus
squared.
256 t.
256t and then plus 0. So there is our equation.
Okay.
What you're going to do now is answer a bunch of questions, okay? We're going to take these one step at a time. We've drawn pictures, I think, once or twice here.
Yep.
Again, this is time and this is height, and if you type this into the equation, this is what it looks like. You're going to have to play around with your window
Yep.
to get this. We're not obviously counting by ones here, but you're going to play with your window till you can see this parabola that's upside down. Now, when does the object hit the ground? Well, it started on the ground for the height. It went up here, and then it does not hit the ground again until it reaches this point,
Right.
or the x-intercept on the other side.
Correct.
So what is the height when it hits the ground again?
Is 0.
It's 0. So we're literally going to say it hits the ground of a height 0 is equal to negative 16 t squared plus 256 t, and we're solving for time,
So we're
which is
solving
our
for
win.
t.
Okay?
Okay. Now, we could do this algebraically, but this one we could also just graph on a graphing calculator.
And
And
since
that's
we
what
have the
highly
picture,
recommend.
use your calculator, figure out what this time value is by
Which will be
calculating the zeros.
16 seconds.
So time is 16 seconds. Okay, now you're solving this equation. If you were to show us some work, you could say I graphed it on my calculator and found the 0.
And sketching that graph is work for us.
Okay? All right, part C. When does the object reach its maximum height? Well, where is the maximum height according to our picture? Again, we're just going to use this graphically.
Right there.
Boom, right up there. That's called a what?
A maximum.
A maximum. What else is it called in
The
a parabola?
vertex.
The vertex, okay? So again, you could do this by hand if you really wanted to, if you remember from Algebra 2 how to find the vertex.
We'll do that next chapter, I think.
We will.
T squared.
For now, we're
negative-
just going to do this all with a calculator.
Okay, so in this time, instead of calculating a 0 or calculating an intersection, we need to calculate a maximum.
We're going to calculate the maximum. Now, on the bottom of your calculator, it's going to give you an x and a y value of that maximum.
I got them. They're 8
What are they?
and 1024.
So when your calculator calculates this maximum, it tells you that the x value is 8 and the y value is 1024.
Correct.
What is our answer to part C? Because we'd like to answer the question that's asked, unlike earlier when I just answered the question I wanted to. Okay?
Well, it says when. When is a time, Mr.
What is a
Leckie?
time? So time is equal to what?
Well, that's the x-coordinate 8.
8 seconds.
Kind of makes
Seconds
sense.
is spelled with a C. Okay. Then the part D says, what is the maximum height?
Well, the height is the y value, so that's 1024 feet.
1,024 feet.
I think that's it.
Is it that easy?
It's really that easy.
It really is. Really what you're doing is using your calculator, the skills you have, but answer the question that's asked. Don't
Absolutely.
answer the question that you feel like answering.
Absolutely.
Okay.
All right, so one more part here, and we're going to go ahead and tie this into what we've been doing with inequalities.
All right, so now we're asking when this object will be at least 768 feet above the ground. Well, we just figured out that it gets to a maximum of 1,024. Correct?
Okay?
So 768 is going to be somewhere less than that. So why don't we say that that's
about there.
768, just
That
for fun.
sounds good.
Okay?
You probably want to graph that on your calculator.
Yeah, you might actually want to make that y2, correct?
Absolutely.
All right.
So what's the inequality that we're solving now?
So what we're solving for is our height equation was negative 16t squared plus 256t. And we want it to be at least 768. What does at least mean?
At least means that or more.
Greater than or equal to 768 feet. So we would like to solve this equation. Now we're solving for t's.
Technically, it's an inequality, but yes.
There we go.
Okay. So the first step I did is I found the intersection
Find the
points.
intersection points. And what were they when you find those intersection
They are
points?
4 and 12. Are those nice, pretty numbers?
4 and 12.
Okay.
So once we know that they're 4 and 12, we want it to be greater than, so we want the if this is y1 and this is y2,
Correct.
we want the parabola
Yep,
or the curve to be above or more than
the line.
the line 768. So where does that occur?
Well, that happens between 4 and 12.
It happens right there, doesn't
Yeah,
it?
right there.
So we're between 4 and 12
And we could equal 4 and 12.
because we're equal to here.
Okay,
So we're going to say that our time is between 4 and 12. If we want to use an inequality, it would look like that.
yep,
We could use the interval notation 4, 12
which
with
is even
brackets.
easier.
If you want to get real fancy, you would say time is an element of that set.
Or if you just write bracket 4, 12, we're happy.
We know what you're talking about.
All right, so we have covered some inequalities with absolute values, cubics, and parabolas, and a word problem here.
They're all
So
pretty much done the same way, aren't they?
they really are.
Especially with
Use
the
your
calculator.
graphing calculator. So if you haven't gotten one or lost it,
Focus graphing.
find it. Alrighty,
I think
that's
that'll do it.
We're all done for P6?